All right, let's talk about a skill that sounds super technical, but is really a secret weapon for anyone who wants their computer to do the boring work for them. Yep, we are diving into the world of shell scripting.
You know that feeling, right, when you're stuck doing the same mind-numbing stuff on your computer over and over? Maybe it's renaming 100 files one by one, or cleaning up the same folders every single week. It's a total drag and, honestly, a huge waste of your time. Well, what if I told you there's a way to teach your computer to do all of that for you? That is exactly what shell scripting is all about. Seriously, think of it as your own personal automation superpower. And today, we're going to figure out how to use it. Okay, let's get into the nitty-gritty. Why should you, specifically, spend a little time learning how to do this? What's the real payoff here? This right here, this slide just says it all. On one side, you've got manual work. It's slow, it's tedious, and let's be honest, it's so easy to make a mistake. But on the other side, you've got a script, a set of instructions you write one time that your computer can run flawlessly, in seconds, again and again. The jump in efficiency is it's massive. And this really gets to the heart of why it's so useful. I mean, for sysadmins and developers working on Linux, it's pretty much a must-have skill. For the rest of us, it's just a fantastic way to automate all those repetitive tasks. It also taps into this really powerful idea from the Unix world, chaining small, simple tools together to do incredibly complex things. Plus, it's a great way to quickly test out an idea before you commit to writing a whole big program. Now, this is where scripting really shines. It is the perfect tool for automation, writing those little programs that run your backups or clean up log files. It's also amazing for chaining commands together. Just imagine finding all the text files in a folder, counting up all the words in each one, and then saving those results to a brand new file, all with a single command. That's the magic right there.
But, it's also important to know its limits. Shell scripting is not the right tool for everything. If you need to do some heavy-duty number crunching or build an app with a graphical user interface or handle really complex data, you're probably going to want to reach for a different language, something like C++ or Python. So, how do we actually build one of these things? You might be thinking it sounds complicated, but really, at its core, a script only needs two fundamental pieces. It is so much simpler than you might think. First up, it needs a language. And for most of us, especially on Linux or macOS, that language is Bash, which stands for Born Again Shell. Just think of it as the default language your computer understands when you're typing commands into the terminal. Second, and this part is absolutely critical, your script needs what's called a Sha-Bang. It's that little hash and exclamation mark you see at the very top of a script. Think of it like the label on an instruction manual. It tells the operating system, hey, to understand everything that comes after this line, you need to use the Bash program, which you can find right here. Without it, the system might just look at your script and have no idea what to do. And now for the fun part. Let's see this in action. We're going to watch a very simple script, one that cleans log files, and see how it evolves from a basic, kind of clumsy tool into something much much smarter and safer. Okay, so here's our first version. It's the definition of simple. It gets the job done, sure, but it's a bit of a blunt instrument. It's basically just a raw list of commands you might type into the terminal yourself. You can see it's super direct. First, it changes the directory to where the logs are stored. Then, it uses a simple little trick with that greater than sign to completely empty out two specific log files. And that's it. It works, but it's not very flexible or safe. All right, let's see how we can make this better. Version 2 starts to add a little bit of intelligence. This is where it stops being just a list of commands and starts becoming a proper, well-behaved program. So the first big improvement is that Sha-Bang right at the top. Now we're officially telling the system, hey, this is a Bash script. We also start using variables to hold information, which makes the script way easier to read and modify later. And we add an exit command to give the program a clean, official ending. And this is where it gets really good. Version 3 is the smartest, safest version yet. It's designed not just to do the job, but to do it correctly and prevent you from making common mistakes. Just look at these upgrades. It now actually checks if the person running it is the root user, because you need special permissions to mess with system logs. It uses variables for everything, even the error messages, which makes it super easy to update. And this is the best part. Instead of just wiping the logs completely, it intelligently keeps the last 50 lines. That is so much safer.
It can even take an argument from the command line, so you can tell it exactly how many lines you want to keep. That whole evolution from a simple tool to a smart one, that's really the core of good scripting. So now that we've seen a single example, let's kind of zoom out and look at how pros, like system administrators, use these skills every single day. This is the real power we're talking about. Automating daily backups so you never lose data. Writing scripts that keep an eye on your disk space and shoot you an alert before a server fills up. Automatically adding hundreds of new users at the start of a school year, or running security updates on a whole fleet of machines at once. All of this is done with scripts. Okay, so you've seen the why and the what. Let's finish up with the how. These are the final steps you need to take to actually run that awesome script you just created. It's a really simple two-step process. First, once you save your script, you have to make it executable. You do that with the command chmod +x, which basically gives it permission to run. Then, to actually run it, you type // followed by the name of your script. And that little // is actually really important. It's a security feature. It's you explicitly telling the computer, hey, I want to run the program that is right here in my current directory. This is what prevents you from accidentally running some malicious program that just happens to have the same name as a common command. So there you have it, a little introduction to your new automation superpower. We've gone from why you'd want to do this, to how it all works, and even watched a simple script become a really robust tool. The only question left is, when you think about your own digital life, what's the very first tedious task you would automate?